Hello maths fans, welcome back, and we're now looking at assignment question, year 10 assignment question 46. This is also clip 183. It's one of the interactive questions for clip 183 if you want to find it that way. So again, as I always say with circle theorems, you need to really need to learn them word for word and or at least have them available next to you on a sheet next to you when you're working through these. Okay, and the aim is that you learn these word for word so you can recognise them. Simply referring to them is not going to make you proficient with this sort of problem here. Okay, PA and PB are tangents. As I say, always read the question carefully. So what do we know about tangents? Well, we know that tangents are equal in length from an external point. So PA must be equal to PB. That's something I already know. And the other one that I know is the angle between a tangent and a radius is 90 degrees. And it says O is the centre, so OB is a radius, and so is OA. So even before I've started the question, I know that these two angles here are 90 degrees, and hopefully that's going to help me a bit later on. Okay, anything else we need to know? Okay, we're going to go to the AOB it's asking for now, and they always talk about this angle here, AOB. And if you know your theorems, then that's an angle at the centre. OB is an arm of that angle, and OA is an arm of that angle. If we go from A to the circumference and back to B, we will get an angle that's half of that. Okay, so the angle at the centre is twice the angle at the circumference. So AOB, I'm probably going to write this straight away up here actually. AOB equals 106 degrees. I'm going to write in here in brackets, angle at centre is twice the angle at the circumference. Okay, that's quite a common, comes up quite a lot, that one. Okay, so I'm going to write that in there, 106 degrees. Now, asks for APB now, which almost seems impossible, but hopefully you can see now, because I've already identified these as 90 degrees, can make life easier. Just one word of warning here. Some people look at this quadrilateral and go, oh, it's a cyclic quadrilateral, I'm going to use that. If you give that as a reason at this stage, you won't get full marks. The weird thing about this is actually we could draw another circle in which those 4 points would be on there. We can actually prove it is a cyclic quadrilateral, but we don't know that at this stage in this problem. So what have we got? We've got a quadrilateral, okay, and we know three of the angles. Well, it's become an easier problem now, isn't it? So I need to say this bit though. I need to say about this circle theorem that we've used here. So OBP is equal to OAP, which equals 90 degrees, angle between a tangent and a radius. Okay, so I've got that. So we can say therefore angle APB must be equal to 360, because it's the angle in a quadrilateral, any quadrilateral that's 360. Take away 90, subtract 90, and take away 106. So what's that give us? 180, 286, I'm getting 74. I'm going to check that. I think I'm getting 74, which isn't in my head. Let me pick him up. Yeah, I got that right. I did get picked up on another video for getting something wrong, so I'll just make sure I get that perfectly right. Okay, and hopefully that makes sense and that's helpful to you. Okay, see you next time.